Let's go ahead and summarize our discussion about mixing. Mixing as a process, you can imagine, is enormously important to understand. It's a huge field to understand. It actually tends to describe what the second law of thermodynamics says happens, that you give stuff a chance, it's going to start getting messier. It's going to start mixing together. And this applies to physical phenomena that we see every day involving different phases of matter. What we've looked at in this lecture is the specific case of having a liquid that stuff can dissolve in, and that liquid specifically was water. The dissolving of salts in water, liquids in water, and gases in water. And we've seen that there are cases in which stuff does dissolve and cases when it doesn't dissolve. The rule of thumb for stuff dissolving in water is very much that like dissolves like, and as a result, stuff which is polar, like salts, like ethanol, those will dissolve in water. Carbon dioxide, that will dissolve in water. But it's also the case that I can take a much more subtle approach to understanding whether stuff dissolves in water by looking at the thermodynamics of it and understanding that while my delta S of mixing term is typically going to be positive, it's the delta H term which oftentimes determines whether or not something dissolves in water or not. Whether or not delta H is exothermic or endothermic is going to have an impact. So we had two specific examples to look at that were kind of interesting. One was the dissolving of salt in water, sodium chloride, which was an endothermic process. And the other was the dissolving of oxygen in water, which was an exothermic process. And as we will see when we take a look at chemical equilibria shortly, this idea of Le Chatelier's principle, which says that a system at equilibrium will respond to stresses applied by moving away from them. Well, the impact of that is that if I've got sodium chloride going into water, and that's an endothermic process, one that takes heat in, then if I want to drive a reaction to happen involving sodium chloride, I have to heat the system up because that will drive the system to the right to produce more sodium ions and chlorides. And that's why salt dissolves in water at high temperature. On the other hand, because oxygen is exothermic for dissolving in water, that means that if I heat my system up, then the system says, well, I don't like being heated up. I'm going to shift away from that. That means it's going to shift to the left. And unfortunately, what that means is that I end up putting less oxygen in the water. I make the oxygen less soluble in water as the temperature goes up.